people on Zoom. Oh God, okay. Oh my God, this is going to get recorded. I think I'll just put it off the mic. Okay, if you're a student like me and you want to save money on food or dinner, please grab the food, please grab the sandwiches, fruits, because around 4:30 they'll take all the food away. So what? Better grab it. Get a plate or just try to grab it and
yeah, I think
we should.
There's a chat. I can't see. What is it? We're starting now. I can see it from here. Sorry. Did I?
Okay. How about now?
Can you hear us now? We're starting.
Yes, we can hear you on Zoom.
Okay. Yeah, good. All right. Welcome back, everyone. So I'm going to talk about the third part, which is misinformation mitigation. So we just talked about, like users' perception of misinformation. And the second part, we try to do the automatic detection. But the true, like some recent research has found, even if with the fact-checking services, with automated detection systems, misinformation still spread on the social media platforms. So with that, I think we come to the third part. So like, given the fact that we do have false information or misinformation spread on the social media, and we try to mitigate its negative effect on the platform. So that's what we call the mitigation. So the work in this area, the work on mitigation really falls into two areas broadly, as I showed there on the screen. The first one is the network level of mitigation. That is to the main purpose is to to optimize the spread of information on the whole social network, and so that for people can expose to true information as well, to counter the false information spread on the network. So that's the first area that people work on. And another area that people have worked on is what we call at the personal level. The first one is at the network level. The second one is at the personal level. So we do personalized misinformation mitigation so that we can counter the effect, the negative effect of misinformation at an individual level. Okay, so as what I said, to motivate the problem, despite tremendous efforts for detection from fact-checking services by journalists or from automated systems, misinformation is still going around. And that's the fact we're facing. And so what we say here is mitigation is critically important. And before we talked about the strategies to mitigate the misinformation, we need to first look at the information propagation models. This has been studied for a long time in the area of like studying the social influence on social networks and the information diffusion models on the social networks. So what I have listed there are a few some categories of different information diffusion models. And the first one, it is called multivariate Hawkes process. And it is actually a stochastic process modeling the information propagation along the time. And multivariate means when there are not only one diffusion process, but there are multiple diffusion processes on the network. because it is a social network. There are multiple processes, information spreading happening on the social network. And the second category is linear threshold or independent cascade. This is maybe the most widely used information diffusion model for social networks. And so there are people, the main idea of linear threshold, not only linear threshold, actually I show you on the next slide, there are different types of threshold models. If you look at here, so this is a very interesting survey paper, talks about the different information diffusion models. And this work, actually you can see from the data, you can see back in 2014, people have been studying social influence and information diffusion on social networks. And the threshold model, the linear threshold model is the most widely used one. And after that, there are many other threshold models have been proposed. Basically, this is just say the main idea is if I'm, starting with a few initial seeding nodes, nodes are people, are users, they may propagate information, and when a user becomes in an active state to spread information depends on my neighbors, how many or the proportion of my neighbors have propagated this piece of information. So there's a threshold, that therefore the name of the threshold model. And there are different ways of setting the threshold. And the most traditional one, the classical one, is the linear threshold. That is, when my neighbors, the proportion of my neighbors reaches a threshold, then I will start become activate. I'll become active and spread information. And another class of models is the cascading models. And the cascading model is similar, with again starting from a few seed nodes, and they are active and they spread information, and how much a node would be affected. Not only it's a different way of looking at the cascading. When I become active depends on how much information I receive from my neighbor, so that I can become the cascade. It's not directly using threshold, but again, a similar idea. And then the next class is the epidemic model. So this is like the, it's like for disease, like epidemic model. And there are, a user is modeled in different states. So it's typically it is called the SIR model. So susceptible, infected, and recovered. It's like, contagious disease. You are susceptible, and then you become infected, and then you become recovered. Once you're recovered, then you're not, you would not spread, any information. So that's the epidemic model. So let's go back to, what I showed you just now. And these are the different, and there is also, this one is not a more recent one, information aggregation game. So I have listed all the references if you're interested in the details, and the information, the social influence and the information diffusion on social networks have been studied under these different information diffusion models for a long time. Okay, so particularly recently, and the multivariate Hawkes process was used mainly because it is a probabilistic model that it has a self-excitation process. And it looks at, if you look at here, the x-axis actually is the time, and an event happens, depends on the history, how many times, someone has, this event has happened in the past, and this is along the time, and it is called a Hawkes process. And when it is on a network, when there are multiple processes, it is called a multivariate Hawkes process, talking about the inter-excitement, not only the self-excitement of a propagation. A user, has a prior intensity to propagate information that I receive I have a prior probability, but also I'm affected by others who I'm following on the social network, and that's called mutual excitement process. Okay, and this is actually some work that we have done. And what you see here, the left, we compared the using the rumor data. We compared the propagation process for rumors and non-rumors using the Hawkes process. Actually, what we have done is we applied a multivariate Hawkes process to explicitly measure user influence. What we have found is on the top, you see the usually you see a user social influence as the number of followers, and on the top we see the follower accounts of the different users. But what we when we apply the Hawkes process to analyze to model the process, the information and propagation for the different users, and what we found is it's not the number of followers that high number of followers doesn't translate into high influence, put it that way, straightforward, and that's what we have found. So this is what we call the influence rate. So we derive the real influence under different contexts from different topics. There are many other factors affect how is the real influence of a user on the propagation of information. So the bottom is what we call the influence rate. We derived based on the Hawkes process. And you can see that the distribution is very different from the graph on the top. And once we have derived the user influence, and then we used use that into another variant of the Hawkes process called the marked Hawkes process to predict at what time the user would propagate this piece of information. So that's something we have analyzed on rumors versus non-rumors. On the left is rumors, on the right is non-rumors. You can see the profile are very different in terms of their propagation. So I think I need to hurry up a little bit. And so based on this information diffusion model, and people define the network level of mitigation. So basically, we develop strategies so that we can strategically optimize the way we propagate true news to counter the spread of fake news. Here, I use news very literally, very liberally. I just use news to represent any information, not only specifically newspaper type of news. Okay, so based on the different diffusion models, and people design different ways to maximize the propagation of true information on social networks. Okay, so you can see that it is very tightly coupled with the information propagation model. So this diagram, we have summarized the current work at the network level mitigation. And given this social network misinformation as the mitigation as the overall task, and there are two areas, two specific problems that people have worked on. The first problem is, given this whole social network, who to choose as the debunkers to spread the true information. So that's the first problem. And another problem that people, rather than focusing on selecting who to spread the true information, the second task is rather, suppose that I know these are the debunkers, and how to optimize, how to incentivize these debunkers to spread information. So focusing on the information diffusion part of the problem. So these are the two different tasks. And for the first task of selecting debunkers, and there are generally broadly two approaches. The first approach is what we call the heuristic approach. The heuristic approach, there are a few references I have listed there. There has been some work. So basically, using heuristics to select those users with high social influence or high influence, so that I select those people as the debunkers. So that's what we call the heuristic approach. So there are some work done there in that area already. And on the second approach, is for selecting debunkers is more a learning-based approach. That is, how do I select debunkers in an optimized way, given I have such a some budget of selecting debunkers? And so that's the I will go through each part, each category in more details next. And for the second task of towards given the debunkers are known already, how do we incentivize them to spread true news? So that's the second task. And the task here the existing approaches or more learning-based approaches. So I follow this diagram. I will describe each type of work in more details. Okay, so remember that we are now talking about the first task, selection of debunkers, the heuristic-based approach. So as what I said just now, these heuristic approaches, they are aiming to select the influential users, the users that have the high impact, and hopefully we can block the misinformation propagation or use them to propagate the true information. And you can see that on the social media companies like Twitter, like Facebook, they allow you to report actually, which account is being naughty, and then they close their account. They just basically close the account. But that may not be the best solution. What we are talking about here is we need a more, I don't know, a civil strategy rather than brutally close someone's account. And closing account maybe can be misused by other people, by the adversaries. So rather than doing that, so that's what we call the mitigation task we're talking about. So select the debunkers that can help us to propagate true information to combat the false information. So there are three typical representative works that I have listed here. And the first one, this piece of work, it is based on the epidemic model, based on the information diffusion model, so that they select the influential users to block misinformation or to propagate true information. And this second approach is also a heuristic-based approach, also based on the epidemic model. And then they just say, select nodes and identify they are the ones who are the most has the most negative effect. So block these nodes. And the next piece of work is on selecting the top K debunkers. What they have done is they have designed a dynamic opinion propagation model based on the cascade and the threshold model. And they have done something a bit more complex to model the dynamic opinion process, propagation process. And with that, they select the top debunkers to spread the true information to counter the false information. So these are the heuristic-based approaches. And another class of study is use machine learning to optimize the selection of debunkers to spread true information. Okay, so this piece of work that we have done is, as what I said just now, assume there is a given budget. With this given budget, I want to select the most cost-effective debunkers to spread the true information, okay? And we formulate it as a reinforcement learning problem. And we have an environment. The environment is the social network, and there's a propagation model. Actually we use the Hawkes process as the information diffusion model. Assuming that as the information diffusion model and as the environment, and then the agent select and interact, get the state and the reward to calculate who should be the, we learn and train a policy to select the debunkers to spread the true information. So here is this diagram explains that the learning process, a generic reinforcement learning process. Basically, we have the social network as the environment. The environment has an information diffusion model with it. So we use hogs. Yeah, you don't have to use hogs. You can use other process. And from the hogs, we get the state. So the state is, because it is for reinforcement learning, and this state triggers this actor is the agent. The agent takes an action, and the action is with the state and action, we calculate the reward. And basically, the learning process is, if we get a positive, we have to decide what gives a positive reward, which is a good action for this state. Otherwise, it gives a negative reward, which means we shouldn't do this action. So with this, we have this trajectory, and overall, we learned the overall reward from all these different stages, and we should learn a overall accumulated reward, and that is the maximum. So that's the process of learning, generally reinforcement learning. We just apply it in our context. So in our context, we have the environment. So this is the environment. So the social network is the environment. We assume there are fake news and true news that is spreading. With the Hawkes process, we model each of them, okay? And the agent, the state, would comprises of, like you can see that it has the intensity of the user propagate true or false information. And it also has the number of true or false information within that time, that interval that this user, all these users have propagated the true and fake news. So that's the state. And from here, we train a deep neural network, and then we can come up with a strategy or a policy to select K users at this stage, at this stage K, select a set of users as the debunkers, and the debunkers are selected, and will propagate true news and fake news at certain intensity, basically increase the intensity of propagating true news and reduce the intensity of propagating fake news, and to the environment. And then we do the observation again until we do this reinforcement learning process. We learn an optimized policy that we can select the optimized set of debunkers. You can see this is the reward function that we use. The purpose is the more someone is exposed to fake news, more exposure to fake news, and we mean we give, according to our policy, we give this user more exposure to true news. So basically, if you are someone who has been reading for fake news, we will give you more true news to mitigate it. So that's the reward function, and that will give us the best reward. So it is called correlation reward. And here is the detail. And the objective of fake news mitigation is to maximum the correlation reward, as what I said just now. Basically, this formula here is saying for this stage K, for this state, how do we select the users, UK, and M, this is for the mitigation, and F is for the, M is for the mitigation news, and F is for the fake news. And basically, the whole idea is the state would contain, as what I explained just now, the intensity, the number of true news and fake news respectively. We calculate the reward. If the reward is positive, that means the agent has been doing right. If the reward is negative, then we should adjust our policy. So things like that. So our challenge in formulating this as a reinforcement learning process is this what we call mitigation overlap among the debunkers, because when you select debunkers, if they are independent, then you say it's there can be some, the overall reward is always can be accumulated. You can you can add them up, but if it is on a network, then maybe there are overlapping effect. How do we deal with that? Okay, and also another challenge we are facing is we have a large action space. The action is who should we select as a debunker? So that's the action. So when we have a large social network, who should we select? We can't, select all the subset from the end users. as the potential actions. Okay, so the method we have done, initially a straightforward strategy. If you are familiar with reinforcement learning, you can do that directly DQN. So if you use DQN, formulate it as calculate the Q value, and then you can select the debunker at the time, calculate the next debunker, and put it together unless you have exhausted the whole cost. And then you assume that, all these debunkers put together to give you the maximum reward. But because of the overlapping effect of the debunkers, so what we have done is we try to mitigate the overlapping effect. So we predict the future state and using LSTM so that we can select a set of debunkers that collectively give us the maximum reward. Okay, so the details, you can look into the paper. I think I will skip this part. So basically, starting from standard DQN, one debunker mitigation, we move to with the future state prediction, we extend it to multi-debunker mitigation. Okay, so for the experiments, what we have done, we evaluated the system on synthetic data because we can control the network very easily, the social network very easily. So density and the network size, the average stage length, and the number of stages, we can control these parameters very easily. And for the real world, actually, we use this data set, FIMI. FIMI is a rumor data set. Zhang mentioned just now in that survey paper, they have also curated this FIMI data set on many different real world events, stories about the rumors. So what we have done is we use that as a real testbed as our algorithm. So here are the baselines we have compared with. Basically, random is just like a sanity check, but the others are just the next two are just based on the heuristic approaches, and these are standard learning-based approaches and in the existing literature. So I will just show you briefly the result on the real-world FIMI data set, and we use these three stories, and I will show you an example on the very last one. So this is the example. So this is a rumor. I think this happened in 2015. Do you remember there was a rumor that Putin was missing? And you can see that, the tweets, very interesting tweet. And the very first one is very interesting. And this guy said, well, it's not mail online. I don't know where it is from, but it says, the reason why Putin is missing is because of his girlfriend. He's about to give birth. Like all sorts of rumors about Putin missing. And this one is talking about, there would be a palace coup in Moscow, all sorts of rumors. And this is about the propagation of that of this story, and we experimented on it. And so this is about different time. I won't go into the details, but anyway, this is the reward. Well, the performance, which is measuring the reward that we give, putting in this mitigation strategy policy onto the network, how much reward we get from the mitigation strategy. Okay, so just cautious of time. And as a summary of the network level mitigation, so generally the overall objective is to block misinformation or to maximize the spread of true information on social networks. So optimize at the network level. But with the network, focusing on the network level problem, we haven't considered the individual effect, the effect on the individuals. We haven't modeled or we haven't considered the individual user perception and the user information behavior. And also, we haven't considered the content of the topic or the story of the misinformation. So that's what we need to look at for misinformation mitigation. So next, we look at the network level optimization is good, but it is focusing on the global level of a network level. And how do we do practical intervention strategies to mitigate the negative effect on individuals? So that's what we do. So we want personalization. So recommend personalized corrective true news to individual users to counter the false information. So news recommender system has been around for a long time. It's not something new. You know, like when you log in to your mobile phone, I think if you're using an Apple, Apple will, you know, like recommend news for you. And if you go to anywhere, you know, go to Facebook, go to Twitter, there's feeds, you know, like recommended for you. So news recommendation is has been around for a long time. But the thing here is we want to see from the technical perspective, news recommender systems, they focus on modeling user behavior, modeling user preferences, your interests, so that they can learn what your interests are, so that they can they can recommend news that interests you. But this is only from the user interest perspective. It doesn't consider whether the news or the content is true or false. Okay, and so that's what we are going to do. So if we want to do personalized mitigation based on recommender system, can we cannot just use existing conventional news recommender systems for fake news mitigation, because they only care about your interest. If you like junk food, well, they will always recommend more junk food. If you want to watch video, I recommend more video for you. If you like videos on this, I will, you know, doesn't consider the other aspect, the other dimension of the content of the video. What is, you know, what's the veracity of it? What's the other aspect of it? So that's what we want to do. So what we have proposed to do here is, before we talk about this, let me just say in the literature, before we do this news general misinformation mitigation recommendation, in the literature, there has been work on recommending URL, fact-checking URLs. So, you know, fact-checking, so basically recommend fact-checking URLs to users and towards personalized misinformation mitigation. But the URLs must be there, and so the scope of the mitigation is limited. So what we want to do is to expand it to general misinformation mitigation. So we call it veracity-aware news recommendation for fake news mitigation. So what we have done here, based on the news news recommender system, and in addition to modeling user interests, we also want to model the veracity of the information in the news. Okay, so you can see here, essentially this is the history, the user news interaction history. And from here, we have what we call the event information or the story. You know, are you interested in US election, which is politics, or COVID-19? You know, you're interested in the topics. And then we also look at the veracity information from your interaction history with the news. And then we want to recommend the next piece of news that is relevant, which means that is of interest to you, because from the reading history, we can model that. What's your interest? And we also want to only recommend true news. If there is false news, we wouldn't recommend it. Okay, so that's the whole idea of considering the content and your user interest to do personalized recommendation to to mitigate any false information that a user has read. So we have two goals. The one goal is personalization. The other goal is we're only interested in true news. And then a natural question might be, if you ask, why can't we use our detection system first? we use our detection system first. Only, once we detect that, and then, after that, we do the recommendation. Well, the reason why we're not doing that is, as what I said at the beginning, that is, even if you have detected as true, as detected as false, doesn't stop the users from, from reading it. So we'd rather do it as a online, do the detection and the recommendation in one model, in one end-to-end system. So that's what we're trying to do here. So the challenges for our task and of course, first is how to model the user interests so that we can recommend relevant news. And the next is how to recommend only true news, because we want an end-to-end model. And then how to model this from the sequence of events or the sequence of news topics that from the reading history of someone, how to model the transition so that we can inference users' underlying interest from the interactions, from the transitions of news reading history. And I think I can skip this one, because this is talking about the existing news recommender system focus on the relevance between news, users' personal interest, personal preference. So we can't use it for news mitigation directly. And our problem formulation is like what we see here. So we have the reading history. So of course, given users, a set of users, and given a set of news, and we have the user news interaction in the data, and each this user interaction is for a set of users, and each user has an interaction history, which is a sequence of reading of news. And this formulation, if you do, is similar to in other contexts for, say, for e-commerce purchasing recommendation. They also have this user item interaction. It's just like the item here in our context is a news item, but different from the e-commerce context, the item doesn't have other properties. But what we have here is the veracity, which is a very complex property of the item. Actually, I haven't covered other aspects. For example, there are biases in the news, because if it is a political news, there are other aspects I haven't covered. I just want to say that there are complex attributes associated with the news items compared with the other items. So that's what I mean here, the very last point. A news meta information table contains the title and the abstract of each piece of news. So because we can't include the whole news content there, so and usually if it is on social media, it's usually a link to the news from the newspaper, as well as a summary, so which is a description and the title of the news in there. So our problem is we have this matrix here, which is the user news item interaction. From here, we want to, with this context, we call it context news. So the green ones are true, the red ones are false. Okay, so this is a true piece of true news. This is a fake news, and this is another true news. From the interaction history of this user, he has read both true news and fake news, and we want to figure out what he's interested in. This one is about Justin Bieber, because this is from a particular data set about entertainment news. So and we want to figure out the personal interest of this user, and also want to predict what is the next news that is of interest, and it is also true that I can clarify the information so that we recommend the next. Hopefully it is true, a green, and that is also relevant to the user's interest. So that's our task. And I think I can skip that. So here is our model, and we call it recommendation for mitigation. So what we have done here is, maybe I should explain this. There are 3 modules here, and I show you on this diagram. That's easier. So we have 3 modules here. And the input, the main 3 modules, first is learn the representation. And in learning the representation, remember our input is the news item content together with the user news item interaction history. But we want to distill 2 types of information. One is the veracity information, whether the news is true or false. Secondly, is the user interest. So there are 2 types of representation that we need to, from the input representation. So, so in the representation learning part is need to model the veracity as well as the transition of the event or news topics, so that we can uncover the user interest. And this part is actually this second module, which is the event veracity disentangler. So this part, we need to separate these 2 types of information, and the detail is on the right-hand side. So what we have done here is we use what we call a adversarial autoencoder model. So from the input encoder, we have 3 different parts of the loss function. In the loss function, we have the user interaction, the veracity, as well as the reconstruction loss, adversarial reconstruction loss, so that we can learn the 2 types of representation. You can see the output. One goes to the veracity, another type goes to the modeling the user interest. Okay, so from both these parts, put them together, we make the next news recommendation, because here, from the modeling of the transition of the user of the events and the user interests, so we can model the user interest so that we can do the next news prediction. And also the veracity information tells us whether we should give this recommendation or not. Only when it is true, we give this recommendation. Okay, so the experiments we have done, actually we use this. If you're interested in the fake news net, is the reference is here. So the fake news net data was used for experiment. It is a large scale fake news data set. And we have used these 2 data sets. One is PolitiFact, is on the politic news, and the Gossip Cap is basically talking, is gossips for entertainment. Okay, and here's some experiments of the statistics of the data we use for experiments. And here are the, just to show you what the PolitiFact data set is and the Gossip Cop data set. And the baselines we have compared with include, so this is a classical news recommender algorithm before the deep learning models. And these are all deep learning based news recommender systems. And so the evaluation, when we evaluate these recommendation results, because our purpose is mitigation, it's not only relevance, accuracy of the evaluation. That's what I said. It's not like comparing the user's reading history and verify if it is this news that the reader has read. Not only the relevance is the an important metric for the evaluation, it's also how much the ratio of truth in the recommendation is also an evaluation metric. So this whole concept of mitigation has changed. What do we mean by recommendation? It's not only satisfying your own interest, it is more than that. So that's why we have evaluated both aspects, both the relevance and the veracity. And so on these 2 data sets, the first, the PolitiFact is on the political news, and this is on the classical prediction accuracy evaluation. And you can see the very last one is our model, and on these 2 data sets. Okay, so as what I said just now, we not only evaluate in terms of accuracy, we also evaluate the veracity of the information that is recommended. And from here, And of course, because we have considered the veracity when we do the recommendation, we have the very high, what we call the truth ratio, the ratio of true news. And this is a part of the ablation study, shows the 3 modules. Each part, they play an important role in doing the, in achieving the final recommendation result. So I'll show you some examples here. And in this example here, there are, so the green means true news. And the context, the first row for each user, the first row is the reading history and you know, what we know in the training data. And the second row shows what we have recommended. And in this order, so that the top 5, 1, 2, 3, 4, 5, the top 5 we have recommended. And you can see that we always recommend green colored news. So that is because our purpose in our model, we have the veracity component in the model. And what is underlined shows the news we recommend is relevant to the reader's personal preference, personal interest. So that's some case study that we have shown here. So as a summary, for the personalized mitigation, the purpose is to broadcast corrective true news for fake news mitigation at individual level. And we have the veracity aware personalized news recommendation as an effective strategy for personalized mitigation. And what is important in the model is to model the personal preference and as well as derive the veracity of the candidate news. So for future work, I think what I haven't mentioned there, for modeling the news content, I think for the NLP community, what is really interesting is we just use the, you know, the BERT contextual embedding to model the news content, the title and the description. I think with the development of the language technology, I think something more can be done there to recommend better, you know, like even generate like news for the fake news mitigation. Okay, so what's next? What I really want to see, I think, you know, from the afternoon before, during the break, when we had the chat, what we really want to achieve is to evaluate the effectiveness of these network levels mitigation or the personalized mitigation, the online evaluation of these strategies for changing the spread of misinformation, for changing the user information behavior. So that's what I really want to do. And towards that, actually, this is a system that we built. It is an ad hoc social network system, and it is online there. And we just got the ethics approval. So we want to recruit people to do experiments there to see that if we implement these strategies, will it all really change people's information behavior? Will it change, you know, the propagation, or will change the reading behavior? So that's what we really want to achieve. So we call our system Mirage, and you know, like, so the link is there. And so here are people we have worked with, that my students, and Zhang and Xiaofei and Lin is there, and everyone, and the postdoc Xiuzhen we have worked with. Okay, so I have only covered very briefly. I think, sorry, I'm running over time. So references, we have social media information diffusion models has been studied for a while. So here's a list of the references you can get further information, and also the heuristic-based debunker selection model. And so here are some related studies. And the learning-based network mitigation, there's a literature, a list of relevant literature on here as well. And for the mitigation by recommendation is also a list that you can go to. These slides are online on the ALTA website if you're interested. And I think with that, and welcome questions.
First, thank you so much for this great presentation. It's pretty clear. And I have some dumb questions. So first, it's can you go back to the deep learning framework, DQN, applying to the multi-gated version and original version of the news? Yes, there is a...
Yeah, you're talking about?
Yeah. Right, press one.
This one?
Yes. So I'm just curious about, because you mentioned that the user exposed to fake news, it will receive more multi-gated news, right? So I was thinking, when you're saying multi-gated news, are these two news talking about the same event? I mean, in one instance, are they talking about same event?
All right, okay. So that's a good question. As I said, in this process, we assume that is known. We assume what is the true news, what is the relevant true news for a specific fake news that is known, and we know that. The focus of this problem is what is the, given the history of propagation of this, a particular user, the number of times has propagated true and fake news, and as what I said, the intensity of proposed true news and specific number of true news and fake news this user has propagated, and we give the relevant. This is about, based on the history, we assume that all the news are relevant for, so that's the focus. So we focus on who should we select this person as a debunker. So we assume that is known. That's the limitation of this, as I mentioned at the very beginning, at the very end in the summary. So we haven't considered the individual level information.
Okay, thank you. So another question that might not be really relevant, because you've introduced these fancy frameworks. So I was considering, have you ever considered about the seriousness? Have you ever trying to quantify the seriousness of this rumor? Because some rumors really cause bad effects, but some rumors not, which might need, for those really serious rumors, we might need more large amount of multi-gated news to multi-gate them, right?
Mm-hmm. So again, the answer is, in here we haven't, it's intensity means the frequent, we consider the rumors equally, basically. False is false. There's a binary 0 or 4.
So you see, it's rumor or not, right?
Yeah, that's right. Binary classification, yes or no.
Right. So the last question is, what if we misclassify the rumor? It's a fact, but if we treat it as a rumor, will it cause the same effect as rumor when we spread those? We say it's a fact when we treat it as a rumor. I mean, if we have a system error or something, will it cause some effect like the rumor? It's just a random question.
Okay, you're saying that the effect of a misclassification cost, right?
Especially on rumor, because rumor itself has caused some very bad influence. But what if we misclassify those true facts or true things?
Yeah. All right. Yeah. Well, yes. Again, is we assume that, like the classification is correct, and we do, the follow-up mitigation. So we haven't quantified if there is a misclassification, what is the cost? I think, but that's a very good aspect to good issue and to investigate. Thank you.
Thank you so much. Yes.
Question? Yeah. Oh, sorry.
Yeah, really interesting talk. There was a measure that you used, influence rate. I don't know if I missed the exact definition, or if can you explain it better?
Yeah,
what is the type of measure you used?
Okay. Okay, so I did, yeah, in here,
Yeah, here.
yeah, influence rate. So basically it is a context dependent influence, not, based on the model, we measure, we calculate the probability that this user has an influence in this particular context. So basically it is based on the propagation history of this particular for different news, for different topics, and based on the data, it's a data-driven definition, put it that way. And if you have the number of followers, the interactions between and the timestamps of the event, that is information from there, we calculate the influence rate. It's very much data-driven. That's the point we're making here. It's not the static number of, not static, but the overall number of followers indicate your real influence in specific context. That's the point we're making here.
So does it depend on the network structure as well? Or
Yeah,
something
it
like
depends on not only network structure, but also the history, because the Hawkes process looks at how many, the timestamp, that how many times you have propagated this, you have propagated it, the number of events that it happens, how often does it happen, look at the whole history, and we calculate what's your influence rate.
I see. Okay. Thank you.
All right, then round of applause for Jenny Zhang and Jay Han for the awesome tutorial.
Thank you.